In this video, we're going to talk about solving trig equations with irregular angles. So far, every trig question we've been doing in this course has had an angle of theta, or perhaps x, or perhaps alpha. Now, how do you know what the angle is in a trig question? Well, it's the thing you're taking the sine of. So if you see sine theta, the angle's theta. If you see cos alpha, the angle's alpha. So whatever you're taking the sine of, or the cos of, or the tan of, etc., that's the angle. Well, what we're going to do in this video is we're going to start talking about what if the angle is something like 2 theta? Or maybe the angle is something like half alpha minus 90 degrees. We're going to call those an irregular angle. So in every question so far, we've had an angle of theta or x, etc. Let's say theta for now. And similarly, the domain's been stated in terms of theta. That's the part that says something like 0 degrees less than or equal to theta less than or equal to 360. But what if the domain's in terms of theta, but the angle is something like 2 theta or 3 theta minus 90, something irregular? Then what do? Well, what we do is follow this process. Step 1, we let the angle in the equation, so for example 2 theta, be equal to alpha or some other variable, as long as it's not the same variable used in the question. Then what we do is we restate the domain in terms of that new variable. I'll call that the substitute domain. We then solve for the new variable, alpha, over the substitute domain. But then what we do, step 4, is we solve for theta in terms of alpha, and then convert each of those values that we got for alpha back to theta, thereby answering the original question. All right, let's do one. Suppose we're told that sine of 2 theta equals negative 0.7945, and 0 is less than or equal to theta less than or equal to 360 degrees. The difficulty is the fact that the angle here is 2 theta, the angle here is theta. Well, what we do is we're going to let alpha equal 2 theta. Okay, so I'm going to introduce a new variable. I'm going to call it alpha. But then what I have to do is I have to get this domain in terms of alpha. Well, how do I get theta in terms of alpha? What I do is I multiply it by 2. But I can't just multiply that by 2. It's an inequality, so I have to multiply that by 2. Sorry, that looks like x squared. I have to multiply each of these by the number 2. Okay? So that's what we do here. 0 degrees times 2 is 0 degrees. Theta times 2 is 2 theta. 360 times 2 is 720. So now I've got 0 degrees less than or equal to 2 theta less than or equal to 720 degrees. But if you recall, we just said a minute ago, alpha will be 2 theta. So really what we're saying is that 0 degrees is less than or equal to alpha is less than or equal to 720 degrees. And we're simply going to solve for the sine of alpha equaling negative 0.7945 over this substitute domain. Okay. So this is what we're explaining here. We're solving sine alpha equals negative 0.7945 over the substitute domain. And then we go about our business. By now we might know how to do this really well. We solve for alpha. We see that we've got to find the two y values that have the 2 points on the outside of the unit circle with y values of negative 0.7945. So they're down towards the bottom. We draw a couple of terminal arms. We go about our work. We do the sine inverse of negative 0.7945. We get this value here. That value allows us to get this value. From there, we add and subtract as necessary. And we end up with our answers for alpha. And these are our 4 answers for alpha. Well, everything would be great if we were asked to solve for alpha, but we weren't. We were asked to solve for theta. So then we remember alpha is 2 theta. So by extension, alpha over 2 is theta. So all we really have to do is take each of these alphas, divide them by 2, and we've got our thetas. Sweet. And then we can give therefore statement. Theta is roughly equal to these 4 values. So these 4 values for theta, right here, they're all in the original domain of theta. Now, in the original question, the domain of theta was 0 degrees less than or equal to theta less than or equal to 360. So all of these thetas are in that domain, and all of them solve the equation that the sine of 2 times that theta is negative 0.7945, roughly, because we were approximating. Now, the question asked us to answer rounded to 1 decimal place. I can't remember if it actually said that or not. But if we want to round our answers to 1 decimal place, it's a good idea to keep 2 decimal places throughout our solution. That allows us to have the requested amount of accuracy. Okay, we'll do one more question here. What if the angle given is 1/2 theta minus 90, but the domain is stated simply in terms of theta? Oh, we got a problem, don't we? Well, not really. What we're going to do is we're going to introduce a new variable. Alpha is 1/2 theta minus 90 degrees. And then what we're going to do, you see this original domain given here. We're going to multiply everything by 1/2, and then we're also going to subtract 90 degrees. And we're going to do it from everything. Now, when we do it to the negative 270 and the 450, we're going to get new numbers. When we do it to the theta in the middle, what we're going to get is 1/2 theta minus 90 degrees. But that is alpha. So we're going to have a new number on the left and a new number on the right and a new variable in the middle, and we're then going to be able to solve our equation. So negative 270 times 1/2, subtract 90 becomes negative 225. Theta times 1/2, subtract 90 becomes 1/2 theta minus 90. But remember, that's what we said is alpha. 450 times 1/2 minus 90 becomes 135. So we've got ourselves a brand new substitute domain. So we're trying to solve tan alpha equals 3.55 over that substitute domain. And we do our work and we get a couple of alphas. So each of these alphas right here is in the substitute domain, the domain for alpha. Okay, good. We're happy with that. Then what we do is we want to convert them back to the thetas. So since alpha is 1/2 theta minus 90, we can add 90 to both sides. We can then divide both sides by 1/2, or in other words, multiply both sides by 2. When we multiply both sides by 2, we end up with 2 alpha plus 180 degrees equaling theta. So what we're going to do now with each of these alpha values is we're going to multiply them by 2 and add 180 degrees. So doing that, we get these two answers, negative 31.5 degrees approximately, or 328.5 degrees approximately. Now, I've had students in the past say to me, well, sir, those are not in this domain. The 328.5 isn't. And I say to them, yeah, but this is theta, and this is alpha. I'm not interested in the alpha domain. I'm interested in the theta domain. Well, what was the theta domain? Well, let's take a look. The theta domain was right here, negative 270 to 450. So are our answers for theta both in that domain of negative 270 to 450? You bet they are. And so we've got ourselves some valid answers. So each of these two angles is in the domain for theta given, negative 270 to 450, and each of them each of them is a valid answer to the equation tan of 1/2 of theta minus 90 degrees equals 3.55. Approximately, of course, because we were doing some rounding.